In this lesson, we're going to write a dedicated GPIO driver that we can call from anywhere. This will help us to initialize any pin on this microcontroller. Once the pin is initialized, we can turn that pin on and off using another function that we'll be creating pretty much from anywhere in our program. So let's dive in. Alright, let's talk about the functions that we'll be building today. So the first function we'll be building is called GPIO init, this one right here. If you remember from the reference manual, there are several registers that are called configuration registers. And we use these configuration registers to set up our GPIO peripheral. And then later, we used bit set and reset register to turn on or turn off our port. But before that, we need to set up these configuration registers. And that's the purpose of this GPIO init function. This function is going to set up the mode. We'll set up the output type, output speed, and pull up or pull down. Once these are set up, then we can go ahead and call this function here, which will write to a given pin the value that we want to put. And value will either be 1 for high, 0 for low. Code organization is very important, so we need to be a little organized here. So over here, let's just organize things a little bit and move all these device headers into a directory called device headers. So we need to create a device headers directory. So what I'm gonna do is gonna right click and create folder, and we're gonna call this device underscore headers. Okay, device headers. Perfect. Now we're going to grab all these files and we're just going to drop them into device headers. Perfect. Now we need to create a folder that's called device drivers. So that's where all of our drivers will go. The header files for the drivers. So we're doing the same thing again, creating folder. We're going to call this device drivers this time. Perfect. And now inside device drivers, we're going to create a new header file. And we're going to call this header file gpio.h. So that's how header files end with .h. Perfect. Here's the header file. So what do we need to do inside this header file? So as we talked about, we need to create our GPIO underscore init function. So this function is not going to return anything. So this function is going to be void. And we're going to call this GPIO all capital init. And now this function is going to accept some arguments, so we need some parameters here. First thing, let's just do a little pseudocode, and then we're going to type in the data types and so forth. So what do we want? So in this function, we want which port we're initializing. So port, it will be port, and next one will be pin, what number pin, right? So we have, in this particular microcontroller, we have port A goes all the way to GPIO 12, so there are 13 total, and port B is a little smaller, as you saw in the last code. So we want to know what pin we're going to be initializing. And next, we need to know what mode we're setting this to, mode, and then output type. Where else do we have? Output speed. And lastly, pull up, pull down. So our function is going to receive these and then set these up. All right, so we need to have some data types here. So what data type should be for port? So if you remember, so we're going to be sending this one in. For example, GPIO A, GPIO B. So what is this? Let's click on it actually. All right, it brings us here. So what's the data type for this one? It's actually this one, GPIO underscore type def. So that's the data type should be for that parameter. And this is a pointer. So it needs to have a star. Okay, how about pin? What should the data type be for pin? So pins will be ranging from, at the maximum, they range from 0 to 15, so that's 16 pins. So smallest data type should be okay. All right, how about mode? So how many modes are there on this microcontroller? So if you remember, there are 4 modes. There's input, there's output, there's alternate, and then there's analog. So 4 modes. So we should be okay with just using uint 8, right? And I think it's pretty much the same for the rest of them. I'm just going to copy this and paste it here. All of them will be uint 8. Oh, now look what happened to our function. It's so long, it's starting disappearing over there. So I really don't like that, and I like to do this usually. I like to actually click enter and then make sure that they're all visible to me, so I don't have to go and chase them at the tail end over there. So perfect. So this is our function definition. And now we need to go and create the actual function. So where do we create our function? We create our functions. Functions live in .c file. So we need to go ahead and create that. So before that, we actually need to create another folder over here. And this one is going to be called the same, device drivers, but this one is located in the source directory. So device drivers, finish, and inside this, we're going to create a source file this time, not a header file, but a source file. Perfect. So source file is going to be called pretty much same, GPIO, but ending is C. And the best thing to do immediately, you need to include your header file right here for everything to work well. And how do we actually include our header file? So to include our header file, we need to go inside device drivers, and that's where our header file is located. So that's how we do it. We go device drivers, okay, / GPIO.h. So that should be able to locate our header file. Perfect. Now let's create our GPIO init function. All these data types actually are going to be same. So what I'm going to do, I'm just going to copy all this so I don't have to type. And I'm going to just paste them right in here because they're going to be the same. Okay. All right, let's start filling out our function. So the way we do that, we're going to take port. So we need to start writing to the registers. And our first register we're writing to is mode R right here. So if you remember, first we need to clear the register, and then we're going to write the value that we want to that register. So let's take a look what mode R looks like again. So here's mode R. All right, so mode R register, great. So first we need to zero out the bits that we're interested in. Let's say we are setting up this pin 4. Okay, so we're setting up pin 4. If you remember, this register comes with mostly ones, so it comes in analog mode. So we don't want that, so we want to zero out these 2 bits. It needs to be 0. So to do that, we need to apply a mask that will do that for us. Now in the last lesson, we applied hard-coded mask, which is not the best practice. We need to have a dynamic mask. Since we have the access to our pin number and port, we'll create a dynamic mask that will zero out those bits for us. So the way we're going to do it, we're going to take that mode R register and we're going to AND it with our mask, okay? So how do we actually create a dynamic mask? So ideally, what we would like is our mask would be like this. For example, this would be all ones, all right? So everything would be all ones. So like so. So this is our mask. So this is the one we would like to AND with that register. And when we AND this mask, it will zero out those 2 bits. So hexadecimal for this one would be 0x F F F F. So it'll be all F's at the top. Then it'll be another F. And then this value here. So this is 8 and 4, which is 12, which is actually C. And then F and another F. So this is our hexadecimal value that we need to create to be able to zero out just those 2 bits. So how do we do that? So let's get back to code. Okay, so we're going to end this with a mask. So let's create a mask. So to create a mask, we need binary 11, which is 3, right? So it'll be 3 in hexadecimal. We'll do unsigned long. So we're going to shift this 3 by the number of pins times 2. So why times 2? Because each pin gets 2 bits. So this will shift it to the right place. So at the moment, this will not necessarily give us the number we want. So this is not a mask yet. So this number here, let's say if pin is, let's say, 4, so we'll shift 3 8 times over. So if we have 1, 1, we'll shift it once, twice, 3, 4, 5, 6, 7, 8. So this is the number that we'll end up with, which will be, so in hexadecimal, this will really be equal to 0x 3 0, 0. So this will be our hexadecimal equivalent. But actually in reality, so it's U32. So it'll actually be this number here, 2, 3, 4. So this is going to be the hexadecimal value when this operation takes place. All right. What we need to do is to invert this number, because ultimately what we want is this number here that we talked about. F, 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 C, F, F. So this is the number that we want. So to get to that number, we need to invert this number here. So all we need to do is include this invert here, this inversion sign, and it will do that for us. It will invert this hexadecimal number here with 3 into this. And once we have this hexadecimal number and we AND it, we're gonna zero out those 2 bits. All right? So hopefully this makes sense. So next we're setting this up actually. We're gonna port mode R again. So this time we're setting it, so we need to OR. OR it with what? What are we ORing it with? So we're gonna have a mode. So mode will be either 0, or it'll be 1, or it'll be 2, or it'll be 3. So either one of those. 4 values basically, 0 through 3. And then, so that'll be our mode. So we shift that, we're gonna shift that by the number of pins times 2. Hopefully this makes sense. If it doesn't, write in the comments below and I'll try to explain to you a little better. I like to cast it to uint32 just to make sure that it is 32-bit integer. And I kind of like parentheses to make sure that operations happen within the right order. And also make sure that you put this U here. It just helps to make sure that compiler knows that this is unsigned integer. All right, so we're going to do basically the same thing to the other registers. Okay, next one will be port and output type. Okay, O type R. So that'll be output type, and then I'm gonna AND it. We need to clear it first. So let's just take a look at what output type register looks like. That's the second register that's in line. So output type is a little different. So for each pin, we get 1 bit. So this one will be a little simpler. So all we need to do is to create a mask again. Remember, we always invert the values so that we flip all the bits because we're ANDing. And then what we're going to do is we're going to take hexadecimal 1 and sign long. Now we're going to shift it by the number of pins because each pin gets 1 bit. All right, and this should do it. And then we'll do again port O typer, and then we're going to OR it. By the way, if you feel lost and you don't understand how shifting works and how this bitwise operations work, I have a video over here in the corner. Please go take a look at that. That should actually help you out to understand how this works. I actually have a lot of other videos on this very topic, how we write to and read from registers. So make sure you go to my channel. There are some playlists that talk about those operations. So it's important that you know those. All right, so we're gonna now so let's take output type. So I'm just gonna copy, speed things up a little bit. I'm gonna take output type. We're gonna shift it over by number of pin. All right, and if you remember, we cast it to unsigned 32-bit integer to make sure that it casts properly. Okay, and I also like to include everything inside the whole parentheses. Perfect. So our next one is actually speed register. So let's take a look what that looks like. So speed register is kind of like mode register. So it's actually, our code is actually going to look pretty much the same for the speed register. So what we do, we can just copy this and come down here. And obviously, I'm just gonna delete this comment since we have it at the top there. So let's just change this output speed. It'll be O speed register, and same thing here, O speed register down here. Perfect. So this is actually pretty identical to our mode register. And this is exactly how speed register works. The last one is pull up and pull down. And actually that one will also be very similar. So let's just copy this and paste it down here. And then we're gonna find it here. It's the very last one. Do the same thing for this one. Perfect. I think our function is actually looking good here. Actually, one thing I forgot to do that could cause a big problem. I forgot to change this mode here, and some of you probably caught that. If you did, good job. So I'm gonna just copy and paste this one here. So that's gonna be speed. All right, and this one's going to be pull up down. So I think now this looks good. And if you see a bug like this that I may miss, I'm a human, I can miss bugs too, and I probably will throughout this course. So please feel free to comment below, tell me what I missed. And if you want to offer an improvement to this code, yeah, please do share with everybody. That would be great. All right, now comes the scary part. And if you know what I mean, it's compiling and see if things actually compile, which probably will not in the first time. All right. Ooh, we have 16 errors. That's incredible. So, I can just pause it here and go figure it out and come back and, tell you what I did. But that wouldn't be fun. Let's just do it together and you can see my workflow. So let's go to the very top error and see what it says. Errors are actually good. They tell us something. Let's read the errors. So first one is unknown type. It actually doesn't know what this type is. And that's probably because we did not include our header file in our GPIO.h file. So we need to go over here and we're going to do that include. And if you remember, we moved the header file. So header files are now inside device underscore headers, right? And then inside that, we have STM32 L432 xx.h. Okay. All right. This should actually resolve some of our errors. Let's compile again. Oh, that actually resolved 13 errors that we just had. Perfect. Okay, now we have only 3. Okay, so what does this say? No such file or directory, and it says here it's main.c. Let's go take a look at main.c. Oh, yes. So this is our old code, and if you remember, we had we put it here so that we can reference the registers here. But okay, let's just actually locate this. It's in device underscore headers. All right, and I'm gonna compile again. Look at that, all of our errors disappeared. So it wasn't that bad actually. So all right, so we have no errors and no warnings. That's great. So this is our old code. So what we're doing in our old code is we're manually initializing the pins that we want. So we have a function for it. We don't need that. We're just gonna delete that. And instead, we're gonna call that function that we just created in this main function. But before we do that, we need to include that header file, gpio.h. So main function knows where our function is. And that one is inside device drivers and call gpio.h. Perfect. All right, so now we can just call that function right here. And to do that, we're just gonna do gpio underscore init. And all right, which pin do we want to initialize? So we can initialize any pin that's available on our microcontroller, on our Nuclear board. So let's go take a look at the pin diagram. So here's our pin diagram. So there are 2 ports on this Nuclear board. There are port A and port B pins. So let's choose something from port A. Let's say PA3. Let's do PA3. All right, we're gonna turn on PA3. Perfect. Let's go back to code. Okay, looking at our code, we said it's going to be GPIOA. So we're gonna pass in the port, not pin. What pin number is this? Okay, we said it's going to be pin 3 of GPIOA. The next one is mode. So we're turning on an LED. So this one is going to be output mode. And what is the output mode in mode register? And if you remember, output mode is 0, 1, which is basically 1. Perfect. And what about the other modes? So in our previous code, we just left the default values, and default values are 0. So let's just leave them to be 0 for now. So if you remember, there are 4 registers we're setting. Mode, other one was output type, that'll be 0. Output speed, that'll be 0. And pull up and pull down will be 0. Perfect. And we need to, let's get rid of this code here, and we're going to modify this. So we're setting GPIO A, and we're going to turn on pin. So let's actually go take a look at bit set and reset register quick. So we are doing GPIO 3, which is this one. So we need to set this register. So what do you think we need to write to this register? So if it's 1 here, that's basically 8. So we can write 8 in hexadecimal. That should actually set that register for us correctly. And let's compile, see if our project builds okay. And it does. Now I'm going to hook up the board, and we're going to upload this code to see if our GPIO init function works, and see if we can actually turn on that LED. All right, I have the setup here. I have pin PA3 connected to this green LED, and I'm going to debug now. All right, the first line of code actually is our old code that turns on both GPIO A and B clocks on, so that should be all right. Now we're gonna step in, and over here we're actually going to step into the function. As you can see, we're writing those values into the registers that we just wrote. All of those values that we had are being written, and you can actually see those values over here on the right. So pin is 3, and mode is 1. That's what we're expecting. So we're just going to keep stepping through this until we exit this function. And here we are. We're exiting the function. We're back to main. And actually, this is the line of code that should turn on this LED. So let's see if it does. Oh, I don't know if you can see it or not. LED actually turned on. So great, this works. So our GPIO init function, using the port that we provided, GPIO A, the pin which was 3, and the mode which was 0, 1. And the rest of the values were in default, and we were able to set up this pin correctly, and it turned on. Perfect. All right, so our GPIO init is good for now. There will be some changes to it, actually to the way we call it. And I'll get to it in a little bit here. But it's good, it's working, it's functioning, so we're good with that. Now let's focus on write pin function. So write pin function will accept port, just like with GPIO init. It'll accept pin and then value, and value will be either 1 or 0. So let's implement this in the code. Our GPIO write pin function will be called in the main instead of this bit set and reset register call. Now let's actually comment this out, and we're gonna write GPIO underscore write pin. So what are the arguments that we'll be passing into this function? The first one is port, which will be GPIOA. The next one will be our pin, which is 3 in this case, and the value. So value will be either 1 or 0. So 1 will turn on the pin and 0 will turn it off. All right, so now let's go to our header file, and we're going to write the function definition. So this is a void function, GPIO underscore write pin. All right, so type definition will be similar to the one up above. So I'm just going to copy. Actually, you know what? You can copy all this because these two parameters here are going to be the same. And the one that's not the same is the value, which will be also uint 8 underscore t value. Great. So here's our function definition. So we have port, pin, and value. And let's just actually copy this, and we're going to go over to our C file, and we're going to implement the function here. All right, so what do we want to do? If we want to write to a pin, we're going to be passing value as 1. So if the value is 1, we would like to turn on that pin. And if the value is 0, we would like to turn that pin off. So let's just write that down right now. So if the value equals 1, then let's say turn the pin on, else turn the pin off. Okay, so how do we actually turn pin on? as we saw in the main, we had a register write. That's how we turn a given pin on. So let's write port, and this is the bit set and reset operator, and we're gonna OR this, or the value. So what is our value that we're passing? So it needs to be dynamic. So let's take a look at the reference manual quick, and see what the bit set and reset register looks like. All right, here's our bit set and reset register. So we have, it's a 32-bit register, but the lower half is that goes from 0 to 15 is for setting the bit. So it says bit set BS, and the bit reset is the top part, which ranges from bit 16 all the way to bit 31. So that's the reset part. So for example, if we were to turn on pin 3, we would need to write 1 into this spot here. So that would need to be 1. So that means we shift 1 by the number of pin. Now to turn off a pin, we're going to need to shift 1 by the number of pin plus 16, because now we're dealing with the upper half. So let's take a look at the code again. So what we said is we're going to shift 1 unsigned long integer by the number of pin. This will turn on. Now we need functionality that turns this off. That'll be port, same register. We're gonna be ORing again. So now the code looks very similar to the one above, but the shifting is pin plus 16. And this is to address the upper half of this bit set and reset register. All right, I think this should do it. We're gonna hook up the board and run it on the board to make sure it works. But before that, let me actually compile this, make sure it compiles and we don't have any errors. Great, it compiled fine and we don't have any errors. Now I'm gonna hook up the board and we'll run our code. All right, I have the board hooked up and I'm gonna click debug here. We're gonna skip over this one, and we're gonna skip over this one too. We already went through it when we ran the last time. But I'm interested in stepping into this function. Okay, we're inside GPIO write pin, and if you can see actually over here on the right, you can see the value that we passed in, and it is indeed 1, and the pin is 3. Now we're gonna step in, and this is the line of code that actually should turn on the LED, and let's see if it does. And indeed it did. So our code is working. Now let's restart our code and try actually turning that LED off. So to do that, we're just gonna copy this and paste it here and turn this into 0. Actually, let's also just turn it on again. So first GPIO write pin, we'll turn it on. Then we're gonna turn it off, and then we'll turn it on again. Let's run this. I'm going to skip over these. So this line of code, and I'm not going to dive into the function, but this line of code will turn it on, and it did. The next line of code will turn off that LED, and that also happened. Now this one should turn it back on, and there we go. It's on. Great, so our code is working. So what we've got here is we have GPIO init that initializes a given pin and port, and then we have GPIO write pin function that writes to that particular pin. I'm going to stop debugging. So we have a function initialization function and actually the write function. So this is good. However, there are a couple of things here that we're going to need to tweak. So the issue that we have with this code is a readability. When you look at this GPIO init function, for example, what can you immediately determine that this function does? Well, the easiest thing to determine is that we know that, okay, by looking at this first argument, we know that it is setting GPIO A port. However, other numbers are vague, and we need to engage our brain a little bit and think about the reference manual to be able to understand what we are actually doing. We'd also need to go and hover over this and look into the function definition a little bit and understand what values we're setting. So this is not good. We don't want to do it this way. So in the next lesson, we're going to update this function and we'll pass in more defined values for readability. We'll do same thing with the GPIO write pin. Also in the next lesson, we're going to create read pin function where we can go and read a given pin and see what the value is. We'll also be playing with input and output. So we're going to have a button hooked up to our microcontroller. When we push the button, the LED is going to come on. So stay tuned for that. See you in the next lesson.